Alright, so good morning everyone. I hope this video finds you well. So welcome back to our discussion. Our discussion for today is about summation. So for this discussion, our learning outcomes are 1. Demonstrate a comprehensive understanding of summation and its property. Number 2, solve problem involving summation. Okay, so before we can finally proceed discussing summation, let us discuss first what is a sigma symbol. Okay, and what is the purpose of the sigma symbol? Why do we need to discuss this sigma symbol? So way back then, a short history about sigma. Sigma is a Greek letter sigma, which stands for a sum that is introduced by Leonhard Euler in the 18th century. So Euler, we know him very well, and he is one of our greatest mathematicians in history, and he created and popularized much of the modern mathematical notation that we usually use today. Okay, so Euler used it to denote the sum of a sequence of term in his work on series such as summation of n is equal to 1 plus 2 plus 3 and infinity. So he used this symbol sigma for infinity numbers. Okay? So as time goes by, over time, a lot of mathematicians studied this summation and standardized it into a form that we use today, which is the sum of a sub I from the lower boundary, which is here is 1 up to n. Okay, so we have here Carl Friedrich Gauss, which he used this idea of Euler's summation and expand this idea of Euler's. So another is in the 19th century, mathematicians like Cauchy and Riemann formalized what is the meaning for infinity sum to coverage the sigma notation made expressing this much easier. Okay, so they gather more studies, these two mathematicians, about the infinity sum, which is the summation. Now let us talk about what is a summation. So summation, it is the symbol, this U symbol sigma to represent the sum of a sequence of number, typically following a specific pattern or rule. And the general form of this is summation, the sum of f of I from A to B. So that is read as the sum or sum of f of I from A to B, where the I is the index summation, and A is the lower limit, B is the upper limit. F of I is the function or the term that is being summed, and that term is usually having a rule and a pattern, because based on the definition, right? On the definition, we usually follow specific pattern or rule. So next is, let's have an example here first about summation. So I have an example here, the sum of I from 1 to 5. So what we need to do here, we just simply substitute the value from 1 to 5, from the lower boundary, which is 1, to the upper boundary, which is 5. So just simply substitute that in the I. So that will be is equal to 1 plus 2 plus 3 plus 4 plus 5, which is equals to 15. So that is our first example. Another example here, we have here sum of I squared from 1 to 4. So again, we just have simply substitute the value from the lower boundary 1 to the upper boundary 4, which is 4. So that will be equal to 1 squared plus 2 squared plus 3 squared plus 4 squared, and that will be equal to 30. Alright, so good job. I hope everyone is learning through this video presentation. So let us move forward. So next is, let's talk about the property of summation. Okay, so one of the property of summation is the linearity of summation, which is one of the linearity summation is sum of two sequence. So that sum of two sequence is written as sum of quantity a sub I plus b sub I from 1 to n, which can be written as sum of a sub I from 1 to n plus sum of b sub I from 1 to n. Okay? So I hope everybody is learning and absorbing all this information. So for more knowledge, let's have an example for this problem. For this property. Okay? So let's have an example here. I have here the sum. Okay? The sum of quantity I plus 2I from 1 to 3. So this can be written as the sum of I from 1 to 3 plus the sum of 2I from 1 to 3. Okay? So that will be equal to 1 plus 2 plus 3 plus 2 quantity 1 plus 2 plus 3. So 1 plus 2 plus 3 is equal to 6 plus 2 we have to multiply the 2 to 6, so that's 12. So we have here a total of 18. Alright. Next property under linearity of summation is the constant multiple. So constant multiple can be written as the sum of C multiplied to A sub I from 1 to n. And this can be written as C multiply to the sum of A sub I from 1 to n. Okay. Alright, so that is our second property. I hope you at least write something on your notes so that you can still remember or have a recap of our properties. Okay? So let's have an example under the constant multiple. Okay? So I have here the sum of 2i from 1 to 4. So this can be written as 2 multiplied to the sum of I from 1 to 4. So you just have simply substitute the value from 1 to 4 to our I and multiply it to 2. So that will be 2 multiplied to the quantity of 2 quantity 1 plus 2 plus 3 plus 4. So that will be equal to 2 quantity 10. So that's equal to 20. Okay, so our final answer here to this problem is 20. Good job. Good job, everyone. Next, we have here the second property, which is summation of a constant. When we're doing summation of a constant, what we just need to do is simply multiply the value of C to n. Okay? So if we have sum of C from 1 to n, that is equal to C times n. Okay? So I have an example here. For this example, I have the sum of 3 from 1 to 5. So sum of 3 from 1 to 5 is simply equal to 3 times 5. Good job. So 3 times 5, so that is equal to 15. Good job. Next is we have, good job. I can see everyone is truly learning. Next is we have index summation. So index summation, an index summation means we're summing a series of terms that depends on an index variable. Usually, index summation used I, j, k, or n as variable. And the index tells us which term in the sequence were added at each step. Okay? So, general form is the sum of a sub I from m to n. Okay? So let's have an example here. I have an example here for index summation. I have summation of quantity 2k plus 1 from 0 to 3. So that can be equal to 2 times 0 because we just have to substitute the value of lower boundary to upper boundary, which is 0 to 3 to rk. So that's gonna be quantity 2 times 0 plus 1 plus quantity 2 times 1 plus 1 plus quantity 2 times 2 plus 1 plus quantity 2 times 3 plus 1. So that will be equal to 1 plus 3 plus 5 plus 7 and a total of 16. So our final answer on this index summation problem is 16. Good job. Good job, everyone. Another is we have the double summation, or also known as nested summation. Good job. So this is written as sum a sub a times j from which the I is from 1 to m and j is from 1 to n. Okay? So for you to clearly understand what is nested summation, I will give you like the best example for this one. Okay? So an example for this is sum of some quantity I plus j where I is from 1 to 2 and j is from 1 to 3. So first, what you need to do here is to provide first the value of I. So we have here a lower boundary of I from 1 to 2. So we have 1 and 2 only. Okay? So first, when I is 1, what is the final value together with the j? So when the sum of quantity 1 plus j from 1 to 3, okay, because our I is 1, so we have to substitute already the 1 onto the I index. So we have sum of quantity 1 plus j from 1 to 3. So simply substitute the value of the j, which is 1, 2, and 3. So that's quantity 1 plus 1 plus quantity 1 plus 2 plus quantity 1 plus 3. So that is equal to 2 plus 3 plus 4, which is equal to 9. So our value is 9 when I is 1. So how about when I is 2? Okay? So when I is 2, so we just simply need to substitute the value of 2 to the I index. Okay? And get the sum of quantity 2 plus j from 1 to 3. So that is 2 plus 1, quantity 2 plus 1, plus quantity 2 plus 2, plus quantity 2 plus 3. So that is equal to 3 plus 4 plus 5, which is equal to 12. So when I is 2, the value is 12. So we have 9 plus 12. So that is equal to 21. Okay? So it means that in the double summation, sum of some quantity I plus j, wherein I is from 1 to 2 and j is from 1 to 3, that is equal to 21. Okay, so I hope you learned something through this discussion, and you have learned something about the property of summation. Okay. Okay, so I have prepared here a practice task, 2 numbers, so that you can test yourself as well if you learn something from our discussion. Okay, and you can try it on your own and test yourself if you have learned something through the properties that we have discussed. Okay, and for this one, thank you so much for listening to this video presentation, and I hope this video really finds you well. Have a good day, and thank you, everyone.